IBPS PO English Q1 to Q30.mp3.
Usually when we talk about a language, there's this expectation of subjective interpretation.
Right, like reading poetry or something.
Yeah, exactly. You look at a stanza and the teacher asks what it means to you, but then you step into the world of competitive exams and suddenly all that fluidity just vanishes.
Oh, totally. It becomes rigid.
It really does. It feels like highly structured math. And that invisible math is exactly what we are decoding today in this deep dive.
I love that framing.
We are getting into the English language section of the 2026 IBPS PO Prelims. Specifically, we're going to master the first 30 questions of Model Paper 07.
And, I want to take a quick moment right here at the start to speak directly to you, the listener.
Yeah, please do.
I know this transition from casual reading to strict rules-based English can feel incredibly intimidating.
Especially if you're not an English major.
Exactly. It doesn't matter if your background is in engineering, commerce, or the arts. These exams often feel like this massive wall of confusing text, purposely designed to trip you up.
They really do.
But I promise you, we are going to unravel every single conceptual roadblock together. You absolutely have the ability to master this. We just need to find the underlying logic.
I love that. We're going to build that logical framework step by step. So we'll start with macro-level reading comprehension, figure out how paragraphs fit together contextually, and then zoom all the way in on the micro-level grammatical mechanics.
Spot on.
So let's jump straight into section 1, macro comprehension. This is a passage about urban Indian grocery habits, basically the explosion of those 10-minute delivery apps versus the traditional local Kirana stores.
Right. And before we can fix broken sentences later on, we have to prove we can extract accurate meaning from a complete text.
Like a detective.
Yes. This section tests your ability to retrieve explicit details, evaluate inferences, and grasp contextual vocabulary.
I always think of it like being at a crime scene. You can't just guess what happened. You have to look for actual evidence. So let's find the evidence for question 1.
Let's do it.
It asks, according to the passage, quick commerce orders arrive from small neighborhood warehouses called what? The options are cold rooms, mega malls, dark stores, cargo hubs, or farm gates.
Well, acting as detectives, we strictly check the text. Part 1 explicitly defines that these orders arrive from small neighborhood warehouses called dark stores.
No mention of cargo hubs or anything.
None at all. So, by pure detail retrieval, the definitive answer to question 1 is C, dark stores.
Got it. And because of that incredible speed, we see a direct effect in question 2. It asks how the convenience of quick delivery has made the business. The options are dull, risky, brisk, illegal, or seasonal.
Again, we just follow the textual evidence.
Yeah.
Part 1 notes that because snacks and candles are reaching doorsteps in minutes, the convenience has made business brisk.
Okay.
It's a direct cause and effect stated by the author. Therefore, the accurate choice for question 2 is C, brisk.
But obviously, the traditional shocks aren't just giving up, which brings us to question 3. How have some Kirana stores responded?
This is a fun one.
Did they shut down, raise prices, sue the apps, sell only online, or take orders on messaging apps? I'd almost expect them to launch their own full-scale apps, honestly.
And that's a really natural assumption based on the real world. But this is where the exam tests your discipline. We can't assume.
We just have to read.
Exactly. Part 2 of the text provides the exact mechanism. It concerns that some Kirana stores now take orders on messaging apps and deliver to nearby lanes themselves.
So they adapted.
Yes, using tools they already had. So for question 3, the correct answer is unequivocally E.
That adaptability relies heavily on their history with the community. Setting up question 4. Which old strengths of the corner shop still matter today?
Is it speed, ads, trust, apps, or size?
Yeah, those are the options. Speed and scale, ads and discounts, trust and credit, apps and drones, or size and location.
Well, analysts in the text point out that while the apps have speed, the Kirana stores have generations of community connection. The text specifically names trust and credit as their enduring strengths.
Because you can buy on credit.
Right, which an app won't allow. So for question 4, the correct option is C.
Now here is where we shift gears from just retrieving facts to actually evaluating an inference in question 5. It asks, which of the following is true based on the passage?
And the options.
Do Kirana stores shut down? Are dark stores walk-in? Do apps deliver in 10 hours? Do Kirana stores refuse phone orders? Or do analysts expect both models to coexist? Why is an inference trickier here?
Because an inference requires you to synthesize the entire narrative arc, rather than just pointing to a single sentence. You have to grasp the author's ultimate conclusion.
Right.
Part 2 concludes with a prediction that the two models will learn to live side by side. This completely neutralizes extreme options like Kirana stores shutting down. So the answer to question 5 is E. Analysts expect both models to coexist.
Makes total sense. Now we move into the vocabulary portion. Question 6 asks for the word closest in meaning to brisk. The options are slow, rapid, fragile, secret, or costly.
Context is your best friend here. We already established that brisk describes a business model built on 10-minute deliveries.
So it has to be fast.
Exactly. In this highly active context, brisk means rapid. It's the exact synonym required, making B the answer to question 6.
Question 7 does the same for the word wary. The passage says the Kirana stores are wary of losing customers. Are they careless, eager, cautious, proud, or joyful?
Think about it.
If I'm afraid of losing my livelihood, I'm definitely not eager or joyful.
You're on guard. If a threat exists, your natural response is watchful self-preservation. You become cautious. The other options contradict the context. So for question 7, the answer is C, cautious.
Wrapping up the passage with question 8, we need the opposite of the word ignore. The options are overlook, neglect, skip, heed, or forget. This feels like a trap.
It absolutely is a trap. 4 of these words mean almost the exact same thing.
Yeah, overlook, neglect, skip, forget.
Right. They all belong to the family of paying no attention. If we want the definitive antonym, the total opposite, we need a word that means to actively notice.
Which is heed.
Yes. Therefore, question 8 is D.
Fantastic. So we've successfully extracted meaning. Now we transition to actively rebuilding texts in section 2, covering cloze tests and parajumbles.
This is where the math really starts showing up.
Are these essentially just linguistic jigsaw puzzles? Like, are we just trying words to see what sounds good, or is there a deeper logic?
I love the jigsaw analogy, but I have to add a crucial caveat. We are absolutely not matching shapes by feel or sound.
Really?
Yeah. In English, transitional words, thematic progression, and cause and effect logic act as the rigid interlocking edges of the puzzle pieces. Every piece has a mathematically precise slot.
Okay, let's test that on a cloze test about monsoon floods, covering questions 9 through 13. The passage starts, every monsoon, several Indian cities come to a blank, which is question 9, as roads disappear underwater. The choices are festival, profit, meeting, party, or standstill.
Think about the physical reality. Roads disappearing underwater completely halts movement.
So it's a standstill.
Exactly. A complete halt is a standstill. Words like festival or party clash entirely with the severe infrastructural crisis. So question 9 is definitively E.
That brings us to question 10. Choked drains, blank with plastic waste, cannot carry the rain. Are they polished, decorated, painted, opened, or clogged? I mean, who is painting a drain in a flood?
Precisely. Context eliminates the absurd options immediately. Drains filled with plastic waste are physically blocked. The only viable adjective is clogged. So, question 10 is E.
Moving to question 11. Civic bodies now blank desilting drives before the rains. Cancel, mock, forbid, undertake, or postpone.
We have to assume the logical role of a civic body, which is to help the city. Civic bodies carry out or initiate these cleaning drives.
So they undertake them.
Right. Canceling or forbidding them contradicts their duty. Therefore, question 11 is D, undertake.
But the very next sentence introduces a twist for question 12. It says, yet the effort often starts too blank, early, late, loudly, gently, or brightly.
Here are those puzzle edges. The conjunction yet is your biggest clue. It signals a contrast or a failure.
Because the floods are still happening.
Yes. The effort failed because it started too late, which validates B over early. Question 12 is B.
That makes the mechanics so clear. Finally, question 13. Citizens who stop dumping garbage into drains can blank the problem at its source. Worsen, ignore, tackle, praise, or spread.
Stopping the dumping is a proactive, positive solution. It requires an active verb denoting problem solving. Citizens can tackle the problem. So question 13 is C.
Wow, okay. Now for the parajumbles, covering questions 14 through 17. We have 5 scrambled sentences, A through E, about urban gardening.
This one is purely structural.
Sentence B states market vegetables travel hundreds of kilometers. E says by the time they reach our plates, freshness is lost. C suggests a few balcony pots are enough for a garden. A lists the benefits, like better taste. And D concludes it's no wonder urban gardening is winning fans. How do we start?
We look for the logical trajectory. Most informative paragraphs follow a specific arc. They state a problem, show the consequence, offer a solution, explain the benefits, and provide a concluding thought.
Oh, wow, that's practically a formula.
It really is. So let's map it. Sentence B is the problem, the massive travel distance. Sentence E is the direct consequence, lost freshness.
Then C is the solution, the balcony pot.
Exactly. Sentence A lists the benefits of that solution, better taste.
Yeah.
And sentence D summarizes the entire phenomenon. So the inviolable sequence is B, E, C, A, D.
Armed with that sequence, the questions take 5 seconds. Question 14 asks for the first sentence.
Based on our chain, that is sentence B. Question 14 is B.
Question 15 asks for the fourth sentence.
Following B, E, C, A, D, the fourth link is sentence A. Question 15 is A.
Question 16 asks for the last sentence.
The conclusion is sentence D. Question 16 is D.
And question 17 asks which sentence comes immediately after sentence C.
In our established sequence, A directly follows C. So question 17 is A. Once you build the framework, it's effortless.
It really changes how you look at a paragraph. Okay, let's take out our magnifying glasses for section 3, the micromechanics. This is error spotting and phrase replacement.
My favorite part.
I have to push back a bit on how people study for this. When I read a sentence, I usually just trust my ear. If it sounds right, I assume it's correct. Isn't that enough?
It is the most common trap candidates fall into. Relying on what sounds right is dangerous because everyday spoken English is full of grammatical errors.
That's fair.
We accept them in conversation, but the exam does not. We have to analyze the strict syntactical map governing the sentence.
Okay, let's test my ear against the math on question 18. Find the error in this sentence. Part A, each boy and each girl. Part B, in the class. Part C, were given. Part D, a prize yesterday.
What does your ear say?
To my ear, boy and girl means 2 people. 2 people means plural, so were given sounds totally fine.
And that is exactly how the test makers want you to think. But here is the grammatical math. The word each is a powerful determiner. Think of it like a linguistic spotlight.
A spotlight?
Yeah, no matter how large the crowd is, the word each forces the spotlight onto just one single person at a time. It forces the subject to remain singular, absolutely, regardless of whether you join nouns with and.
Wow, okay.
Therefore, the plural verb "were given" in Part C is mathematically incorrect. It must be corrected to the singular, was given. The answer to question 18 is C.
So each basically acts as a mathematical one. That is fascinating. Let's look at question 19. No sooner had the train, that's A, left the station, B, than it began, C, to rain heavily, D.
We're looking for structural pairings here. The phrase "no sooner" is quite dramatic. Because of that drama, English grammar demands 2 things.
Which are?
First, it mandates a specific correlative conjunction later in the sentence, which is then. Second, it triggers something called subject-auxiliary inversion.
Okay, you just lost me with subject-auxiliary inversion. What does that actually mean?
It just means the sentence flips the normal order of words to put the spotlight on the action. Instead of saying the train had left, the dramatic "no sooner" forces the helping verb "had" to jump in front of the subject, the train.
Oh, I see.
So it becomes "had the train." This sentence executes that formula perfectly. It has the inversion in Part A and the then in Part C. There is no error. Question 19 is E.
Got it. It flips the words to build tension. Let's move to question 20. She is not only A, good at singing, B, but also C, at dance, D.
This is a test of parallelism. Think of a sentence like a balancing scale. Not only is on one side, but also is on the other.
Right.
Parallel structure mandates that whatever grammatical form you put on the left side, you must put the exact same form on the right. In Part B, we have the gerund, singing, an ing word. But in Part D, we just have the noun, dance.
The scale is unbalanced.
Exactly. To fix it, dance must become dancing. The error is in D. Question 20 is D.
Okay. Question 21. 10 kilometers are A, long distance, B, to walk, C, in this heat, D. Now, kilometers has an S on it. It's plural. My ear is telling me R is perfectly fine.
Your ear is being tricked again by the S. This is the classic unit of measurement rule. When we talk about a specific measurement of distance, time, or money, we usually aren't talking about individual units.
Right. I'm not walking 1 kilometer 10 separate times.
Exactly. You are thinking of the entire journey as one single exhausting chunk. Because it is viewed as a single unified quantity, it acts as a singular noun. It necessitates the verb is. 10 kilometers is a long distance. The error is in Part A, making question 21A.
That makes total logical sense when you explain it as a single chunk of effort. Question 22. He, as well as A, his friends have, B, agreed to join, C, the new project, D.
This tests the primary subject rule. When you join subjects using the connective phrase "as well as," the grammar engine only cares about the very first subject.
Which is he.
Yes, and he is singular. The phrase his friends is basically just extra baggage being dragged along. It does not change the mathematical number of the main verb.
Ah, so have is wrong.
Correct, because he is singular, have is incorrect, it must be has agreed. The error is in part B. Question 22 is B.
Let's apply this strict logic to phrase replacement for questions 23 to 25. Question 23. The two brothers quarreled, quote, among themselves over the property. We need to replace among themselves. But why? Don't among and between mean the same thing?
In casual conversation, people mix them up all the time. But formally, they are strictly separated by numbers. The preposition between is explicitly reserved for exactly two entities. Okay. It actually comes from the Old English word for by two. Among is used when there are three or more entities in a crowd. Since the sentence specifically states there are two brothers, the phrase must mathematically be replaced with between themselves. Question 23 is A.
Question 24. She insisted, quote, to go home before dark. I need to replace to go.
This tests a concept called prepositional collocations, basically words that naturally lock together in English. The verb insist categorically takes a preposition on.
Insist on.
Right. And after a preposition like on, verbs usually transform into an ing form, a gerund. It is never followed by a to action, so the only grammatically acceptable lock and key combination is insisted on going. The accurate resolution is D. Question 24 is D.
Okay, question 25. Hardly, quote, he had reached the office when the phone rang.
We saw this exact same mechanism back in question 19.
Oh, with the invert?
Yes. The word hardly is a negative adverb that creates a sense of sudden drama. And just like no sooner, it triggers that inversion rule. The auxiliary verb, had, must mathematically swap places and jump in front of the subject he to highlight the action.
So it becomes had he reached.
Exactly. The answer to question 25 is B.
You know, seeing the matrix of the language like this is actually really satisfying, and that brings us to section 4, the finishing touches, fillers, vocabulary, and idioms. I always thought filling in blanks was completely subjective.
It is a massive misconception that vocabulary questions are subjective. Just like grammar, context acts as a highly specific lock, and it will only accept one exact linguistic key. Let's look at the fillers to prove this.
Okay, question 26. The librarian blanks silence so that readers can blank without disturbance. The options give us pairs, breaks and concentrate, enforces and shout, enforces and concentrate, or forbids and study.
Think about the logical fundamental purpose of a library. It is a place for study. Therefore, a librarian's action must enable that study. If the librarian breaks silence or forbids study, it defeats the entire purpose of the building. Enforcing silence enables readers to concentrate.
That makes sense.
The only key that fits this dual logical lock perfectly is C, enforces and concentrate. Question 26 is C.
Question 27. The bridge was blank for repairs, so commuters had to take a longer blank.
This sentence sets up an undeniable cause and effect relationship. If a bridge is undergoing repairs, the cause is that it must be closed.
Right.
The direct effect of a closed bridge is that drivers are forced to detour, which means taking a longer route. If the bridge were open, there would be no longer route. The logic demands option A, closed and route. Question 27 is A.
Question 28. Scientists blank the samples carefully before blank their findings.
We are looking at the inviolable chronological sequence of the scientific method here. You simply cannot publish a paper before you analyze your data.
And if you ignore the samples, you have nothing to publish.
Exactly. The data must first be analyzed prior to publishing. Option E is the definitive logical choice. Question 28 is E.
Moving on to vocabulary, question 29 asks for the word most opposite in meaning to transparent. The options are opaque, clear, glassy, visible, bright.
Transparent describes a material that allows light, or metaphorically the truth, to pass completely through it.
Like a window.
Right. If we were looking for the absolute opposite, we need a word that describes a material blocking light completely. That exact scientific term is opaque. Words like clear, glassy, and visible are actually near synonyms to transparent. Therefore, the antonym is A. Question 29 is A.
Finally, question 30 tests an idiom. What is the correct meaning of the phrase to sit on the fence? To relax, guard a property, take a big risk, avoid taking sides, or interrupt a meeting. I love idioms because they paint such a literal picture of a figurative concept.
They really do. Idioms are almost never meant to be taken literally. Visualize the metaphor. You are sitting on a fence that divides two different properties. You are balancing right in the middle, refusing to put your feet down in either yard.
You aren't committing.
Exactly. It is completely divorced from literally guarding a property or relaxing. It means to remain neutral, to avoid taking sides. Therefore, the answer to question 30 is D.
And just like that, we've navigated the entire linguistic landscape. We've gone from extracting big picture facts about neighborhood dark stores to building the logical chains of urban gardening paragraphs, all the way down to calculating the singular math of the word each.
And if you are listening to this and preparing for your exam, I truly hope you feel a profound sense of relief right now.
I know I do.
Acing this English section is not about blind memorization, and it certainly isn't about hoping a sentence just sounds right to your ear. It is entirely about identifying the logical, mathematical trajectories of the language. I have deep, immense confidence in your ability to take this robust, evaluative framework and apply it successfully on exam day. You have the tools now. You can do this.
Absolutely. You are equipped and ready. So I want to leave you with one final real-world challenge. The next time you read a news article online, or even just an email from a coworker, try to spot the invisible math of the sentences. Where is their subject-verb agreement? Did they use among when they should have used between? Are they sitting on the fence with their phrasing? English isn't just a trap on an exam paper. It's a beautifully complex system happening all around you every single day. Go out and observe it. Until next time, happy studying.
You know, when you first walk into like a massive, fully equipped gym, it is so easy to just stand there, look at all the heavy machinery and feel completely paralyzed.
Oh, absolutely.
You see people deadlifting 3 times their body weight and your brain just short circuits. You think, where do I even start?
It's a completely natural reaction, honestly. The sheer scale of it just freezes you in your tracks.
Yeah.
You focus on the overwhelming size of the entire building instead of, just looking at the single 5-pound dumbbell sitting right in front of you.
And honestly, that is exactly what it feels like to open a standardized test and stare down a massive block of math questions.
Oh, for sure.
So today, we are stepping into that mental gymnasium together. We're looking at a really specific stack of sources today. Section 2 of the IBPS CRP POMT 2026 Model Paper 07. We're diving deep into the Quantitative Aptitude section, covering questions 31 to 65. So if you are actively prepping for this exam, or I don't know, if you just want to sharpen your problem-solving toolkit, you're exactly where you need to be.
You really are.
Because our mission today is to walk through this entire section sequentially, like without skipping a single question.
And it is so important to frame it that way. I mean, I want to validate the effort you're putting in just by being here and listening.
Yeah, it's a lot.
It is. The goal of this deep dive isn't to drill rote answers into your memory. It's about understanding the architecture of quantitative problem solving.
Right.
By walking through every question in the sequence, you're going to build a sturdy, unfragmented framework. We're basically going to break down that intimidating gym into a series of simple, manageable movements.
Okay, so let's warm up. Looking at the top of the section, questions 31 through 35 present us with a classic data interpretation scenario.
The bread and butter.
Exactly. We've got a table showing a company's production and sales in thousands of units across a 5-year span from 2021 to 2025.
So this first block is really a test of your visual organization and your ability to spot traps. Yeah, because data interpretation is about extracting a story from raw numbers. But test makers love to see if they can bait you into doing unnecessary, time-consuming math.
Right. Okay. So looking at question 31, it asks for the unsold units in the year 2023. This feels like a simple extraction.
It is.
The table says they produced 54,000 units and sold 45,000. So the difference is just 9. That's 9,000 unsold units. Nice and clean to start us off?
Exactly. You just locate the numbers and subtract. Then question 32 shifts slightly, asking for the sales in 2022 as percentage of production.
Okay, let me look. They sold 42,000 out of the 48,000 produced.
Now, if you just try to divide 42 by 48 in your head, it feels really clunky.
Yeah, I hate that.
But if you look for common denominators...
Well, they're both divisible by 6.
Right, so it simplifies instantly to 7/8.
And this is where memorizing basic fraction to percentage conversions pays off, right?
Precisely. If you know that 1/8 is 12.5%, then 7/8 is just 100% minus 12.5, which gives you 87.5%.
Wow.
It saves you from doing long division on scratch paper.
That's great. Now, question 33 is where I see people panic. It asks for the total unsold units over the entire 5 years.
Oh, yeah. People hate this one.
The immediate instinct is to go row by row, right? Calculate the unsold units for 2021, write it down, do 2022, write it down, and then add up 5 separate numbers.
Which is exactly the time-wasting trap I mentioned earlier.
Okay.
Here is the strategy. It is significantly faster to do the math in bulk. You just keep a running total of the two main columns.
Okay.
If you sum up all 5 years of production, you get 268,000. Sum up all the sales, and you get 227,000.
So you just subtract the total sales from the total production once?
Exactly. 268 minus 227 is 41. So 41,000 units remained unsold overall.
That is such a crucial mental shift. You're doing one subtraction problem instead of 5.
And that bulk math pays dividends later, too. Notice how question 34 is a quick breather. It asks for the ratio of 2021 production to 2025 sales.
Right, that's 40 to 60, which simplifies down to 2 to 3.
Exactly. But look at question 35. It asks for the average annual sales over the 5 years.
Oh, I see it. Because we already calculated the total 5-year sales back in question 33.
Which was 227,000.
Right, we don't have to add anything up again. We just take that 227 and divide it by 5, which gives us 45.4 or 45,400 units.
You got it. Keeping your scratch paper organized and trusting your previous calculations creates incredible momentum.
It really does. So that brings us to the next scenario on the paper, covering questions 36 to 40. This is a text-based caselet about a residential colony of 500 people.
Mm-hmm.
The text says 60% of the residents read a Hindi newspaper and 50% read an English newspaper. But hang on, I have to stop right there.
What's wrong?
60% plus 50% is 110%. How can you have more than 100% of population? That feels like physically impossible.
It does feel impossible, and that momentary dissonance is exactly what the test designers are counting on to throw you off.
It worked on me.
But they provide the key to the puzzle in the very next sentence. It says 20% of the residents read both newspapers.
Ah, so this is a Venn diagram scenario.
Exactly. When you just add the 60% and the 50%, you are double counting the people who sit in the overlapping middle of the Venn diagram.
That makes total sense.
The secret to these problems is translating percentages into absolute numbers immediately so you can anchor your logic.
Let's do that. 60% of the 500 residents means 300 people read Hindi.
Right.
50% means 250 read English. And that 20% overlap in the middle means 100 people read both.
Perfect. Now, question 36 asks for residents who read only the Hindi paper.
Okay.
You take the total 300 Hindi readers and subtract the 100 who are sitting in that overlapping middle section. That leaves 200 people reading purely Hindi.
And question 37 asks how many read at least one newspaper. So we combine the groups, but we have to remember not to double count.
Exactly.
We take the 300 total Hindi readers, add the 250 English readers, which is 550, but then subtract the 100 overlap that we counted twice. That gives us 450 residents who read at least one paper.
Which perfectly sets up question 38. How many read neither?
Oh, well, if 450 out of the 500 total residents read at least one, that leaves exactly 50 people outside the circles entirely, reading neither.
See? It's amazing how a confusing paragraph turns into such simple logic when you visualize the circles.
It really is. Question 39 asks for the ratio of those reading only English to those reading both. The total English readers were 250, minus the 100 overlap, leaving 150 reading only English. So the ratio of 150 to the 100 overlap simplifies to 3 to 2.
Spot on. And closing out the scenario, question 40 asks for the percentage reading exactly one newspaper.
Okay, so just the outer parts.
Yep. You just add the two outer crescents of your Venn diagram. Yeah. The 200 reading only Hindi plus the 150 reading only English. That's 350 people.
And 350 out of 500 is 70%. We just tamed the impossible 110%.
You sure did.
Okay, turning the page. Questions 41 to 45 plunge us into pure algebra. We're tasked with comparing the roots of two quadratic equations, finding the values for x and y, and deciding which is greater.
So this section tests your ability to factor quickly. When you look at a quadratic equation, say x squared minus 23x plus 132 equals 0, as in question 41.
Right.
The underlying mechanism is finding two numbers that multiply to positive 132 but add up to negative 23.
Okay.
Because they multiply to a positive but add to a negative, both roots must be positive numbers once you solve the equation. In this case, 11 and 12.
And for the y equation, y squared minus 17y plus 72, the roots are 8 and 9. Since both 11 and 12 are strictly bigger than 8 and 9, x is definitively greater than y.
Exactly. You are comparing every possible version of x against every possible version of y.
Got it.
Look at question 42. The x equation gives a single root of 8. The y equation gives roots of 6 and 8.
Okay, so because x is 8 and y can be 8, they can be equal.
Right. But x is also greater than y's other value of 6. Therefore, the safest absolute statement is that x is greater than or equal to y.
Makes sense. Question 43 works the same way but reversed. The x roots are 2 and 5. The y roots are 5 and 7. Since x is either smaller than both of y's values or equal to the 5, x is less than or equal to y.
You're flying through these.
But here is where it gets really tricky for me. Question 44. The x equation gives roots of 6 and -2. The y equation gives roots of 3 and -1. The model paper says no relation can be established. But why? We have concrete numbers. Why is there no relation?
Oh, that is the most common trap in this entire section.
Really?
Oh, yeah. To understand why, visualize a number line. The test is asking you to make an absolute universal rule. If x happens to be 6, it sits to the far right on the number line. It's greater than both of y's potential values of 3 and -1.
Right, so in that specific scenario, x wins.
But what if x is its other root, -2? Now x sits further to the left on the number line than both of y's values. Now y is greater. Because the ranges of x and y overlap and literally cross over each other on the number line, you cannot declare a definitive winner. Sometimes x is bigger, sometimes y is bigger. Hence, mathematically, no universal relation can be established.
Oh, that visual of them crossing over each other on the number line makes it click perfectly. You can't make a blanket rule.
Exactly.
Finishing the algebra with question 45. The x roots end up being -5 and -8. The y roots are -2 and -3. You just have to remember how negative numbers work.
They trip a lot of people up.
Yeah, -8 is much smaller than -2, so all x values are smaller than all y values. X is less than y.
You're doing great. Now, moving to questions 46 to 50, the exam shifts gears entirely. We leave the rigid rules of algebra and enter the fluid world of number series.
Missing numbers in a sequence. I actually kind of like these.
They can be fun, and tackling these isn't really about deep mathematical theory. It's about having a mental checklist.
What's on the checklist?
When you see a sequence, always check the difference between the numbers first. If the gap spikes massively, you know it's a multiplication pattern. If it bounces up and down, it's an alternating pattern. It's really just about exposure.
Let's test that checklist. Question 46 gives us 2, 6, 12, 20, 30. The gaps are 4, 6, 8, 10. Oh, you see two ways to look at this.
Let's hear them.
You could just add the next even number gap, which would be 12, bringing 30 to 42. Or looking at the numbers themselves, it's 1 times 2, 2 times 3, 3 times 4. So the final one is 6 times 7, which is also 42.
Brilliant. Recognizing multiple avenues to the same answer means your brain is really adapting.
Thanks.
Now, question 47 is a great example of the bounce. The numbers go 8, 24, 12, 36, 18, 54. It changes direction. It goes up, then down, then up.
Like a weird dance step.
Exactly. When you see a bounce, check for alternating operations. Here, 8 times 3 is 24. Then 24 divided by 2 is 12 times 3 divided by 2.
Oh, I see.
Fast forward to the end, the 18 was multiplied by 3 to get 54. Following the dance step, the next move is 54 divided by 2, which gives us 27.
Got it. Question 48 is visually striking. 100, 121, 144, 169, 196. This highlights why test prep always tells you to memorize your squares.
It saves so much time.
Yeah, these are just consecutive perfect squares from 10 squared up to 14 squared, so the missing piece is naturally 15 squared, which is 225.
Spot on. Question 49 goes 3, 7, 13, 21, 31. Running our mental checklist, we check the gaps.
Okay, they jump by 4, then 6, then 8, then 10, just consecutive even numbers. So the next jump adds 12 to the 31, giving us 43.
Perfect. And question 50 finishes the sequences. 5, 8, 14, 26, 50. Let's look at the gaps.
Let's see, 3, 6, 12, 24. The gap itself is doubling every time. So the next gap should be 48. 50 plus 48 is 98.
That is one valid way to see it. Another way is multiplying by 2 and then subtracting 2.
Oh, really?
Yeah, 5 times 2 is 10, minus 2 is 8. Either mechanism gets you to 98.
I really like how flexible these can be. Okay, pushing forward to questions 51 through 55, we hit a rapid-fire arithmetic section. Simplification and approximation.
Speed round.
Question 51 asks for 68% of 450 minus 22% of 400.
For these, break the percentages into manageable chunks. 68% of 450 can be found by taking 70% and subtracting 2%, or just multiplying 68 by 4.5, which gives 306.
Right.
22% of 400 is straightforward, just 22 times 4, which is 88. 306 minus 88 is 218.
Nice and quick. Question 52 is just testing multiplication speed. 14 times 16 plus 18 times 12. 14 times 16 is 224. 18 times 12 is 216. Adding them gives 440.
Easy enough.
But look at question 53. I have to admit, when an audio script or a test paper throws multiple fractions at me, I tense up.
It's totally normal.
It asks for the sum of 5 over 8 and 3 over 4, and then multiplying that entire sum by 640. Given denominators make my brain want to shut down.
It is an incredibly common reaction. The secret is finding harmony between the numbers. Don't look at them as like abstract concepts.
Okay.
You have an 8 and a 4 as your base denominators. The goal is simply to make them match so they speak the same language. To turn a 4 into an 8, you just multiply by 2.
Right.
But whatever you do to the bottom, you have to do to the top to keep the fraction balanced. So 3 over 4 becomes 6 over 8.
And suddenly it's so much less intimidating. It's just 5 over 8 plus 6 over 8, which is simply 11 over 8. We didn't change the value, just the formatting.
Exactly. And now you just need 11 over 8 of 640.
Which feels like a lot of multiplying.
Don't multiply 11 by 640. Divide first to keep the numbers small. 640 divided by 8 is 80. Then 80 times 11 is 880.
That makes total sense.
Yeah.
Divide first to shrink the problem. Now, question 54 introduces decimals into a square root. The square root of 624.98 multiplied by 12.02. But since this section allows for approximation, we can rely on context clues.
Right. The test isn't asking for microscopic precision here. Treat 624.98 as 625. If you've memorized your squares, you know the square root of 625 is exactly 25.
Yeah.
Treat 12.02 as simply 12. Now, the stereodecimal problem is just 25 times 12. 4 25s make 100, so 12 25s make 300.
That is so much cleaner. And wrapping up the arithmetic, question 55. 4 cubed plus 5 cubed minus 6 squared. Again, memorization is your best friend here. 4 cubed is 64. 5 cubed is 125. 6 squared is 36. 64 plus 125 is 189 minus 36 leaves us with a 153.
Awesome. We have cleared the pure numbers. Now, starting at question 56 through 60, we have to actually apply these concepts to word problems.
Dreaded word problems.
Yeah, we're translating real-world scenarios into algebra.
Let's do it. Question 56 is a classic pipe and cistern problem. Pipe A fills a tank in 6 hours. Pipe B fills it in 8 hours. But Pipe C empties it in 12 hours. We open them all at once. How do we mix filling and emptying?
The mechanism here relies on the inverse relationship between time and work. You cannot just add hours together.
Okay, why not?
If pipe A takes 6 hours to do a job, it means in exactly 1 hour, it completes 1/16th of the job. You have to convert time into speed.
Okay, so Pipe A's speed is 1 over 6, Pipe B's speed is 1 over 8. And because Pipe C is fighting against them, its speed is a negative 1 over 12.
Precisely. Find a common denominator to add those fractions up, which is 24. So 4 over 24 plus 3 over 24 minus 2 over 24. The net work happening every hour is 5 over 24 of the tank. To find the total time, you just flip that fraction back over. 24 divided by 5 hours, which translates to 4 hours and 48 minutes.
Moving to question 57, it's about compound interest. 5,000 rupees invested at 10% for 3 years. We just used the standard formula, multiplying the principal by 1.13 times. The total amount becomes 6,655. Subtracting the original 5,000 means the compound interest generated was 1,655 rupees.
It's the snowball effect in action. Now, question 58 is a mixture problem using a technique called alligation. We are mixing cheap tea costing 200 per kilo with expensive tea costing 260 per kilo to create a blend worth 236 per kilo.
How we struggle to set these up. What is the logic behind the alligation cross?
Think of it like a physical seesaw. You want the balance point in the middle to be 236. On one end sits the 200T, on the other the 260T.
Okay, I'm picturing it.
The distance from the middle tells you how much weight you need. The cheaper tea is 36 rupees away from the center. The expensive tea is 24 rupees away. The ratio of their quantities is exactly the inverse of those distances. 24 parts of the cheap tea to 36 parts of the expensive tea.
Oh, wow. The inverse of the distance. So the ratio is 24 to 36, which simplifies down to 2 to 3. That is such a powerful visual.
It really helps ground the math.
Let's look at question 59, an age problem. 2 people, A and B, have ages in a 3 to 4 ratio now. But 4 years ago, they were in a 5 to 7 ratio.
You just set up a simple fraction equation. Present ages are 3x and 4x. 4 years ago, they were 3x minus 4 and 4x minus 4.
Right.
Set that equal to the old fraction of 5 over 7, cross-multiply, and you find x equals 8. Since B's present age is 4x, B is 32 years old.
Simple enough. But I really want to spend a minute on question 60 because it feels like a trick.
Oh, it is.
A man sells 2 distinct articles for 990 rupees each. On the first item, he gains 10%. On the second item, he loses 10%. What is his overall net result? Instinctively, if I gain 10% and then lose 10%, they should just cancel out to 0, right?
You have just articulated the most common dangerous trap in percentage problems.
I knew it.
It feels completely intuitive that they should cancel out, but they never do. Why? Because the percentages are anchored to different base costs. Let's look under the hood.
Okay, let's break it down.
Let's take the item where he gained 10%. The final selling price of 990 rupees represents 110% of whatever his original cost was. If you divide 990 by 1.1, you realize he originally bought that item for 900 rupees.
Okay, that makes sense. He bought it for 900, made 90 rupees of profit, and sold it for 990.
Now look at the second item. He lost 10%. That means his 990 rupee selling price is only 90% of what he originally paid.
Oh, wait.
If you divide 990 by 0.9, you find out he originally paid 1,100 rupees for that item.
Ooh, I see the trap now. The total amount he paid out of his own pocket for both items was 900 plus 1,100, which is 2,000 rupees. But he sold them both for 990 each, meaning he only brought in 1,980 rupees total. He had a net loss of 20 rupees.
Exactly. Calculating percentages on different starting numbers always shifts the weight. It's a mathematical illusion. A 10% loss on a big number will always hurt more than a 10% gain on a small number.
That is a total aha moment. Okay, we've reached the final stretch of the section. Questions 61 to 65 cover data sufficiency.
My favorite.
And this requires a complete perspective shift, doesn't it? We're moving away from actually solving the problems to simply evaluating if a problem can be solved.
This section is absolutely fascinating because it isn't really testing your math. It is testing your psychological restraint and your executive decision-making.
Right, because you don't actually have to find the answer.
Exactly. You do not get extra points for doing the full math. You just need to know if you have the right puzzle pieces. You need the confidence to look at the data, say, yes, this is enough, and then physically stop yourself from solving it.
Let's put that restraint to the test. Question 61 asks to find Ravi's present age. Statement 1 says Ravi is 6 years older than his sister. Statement 2 says 5 years ago his sister was 24.
Evaluate them strictly in isolation. Statement 1 alone is useless. It's just a relationship with no anchor.
Right.
Statement 2 alone gives us the sister's timeline, but mentions nothing about Ravi. But if you put them together...
You know the sister's 29 now, which means you could find Ravi's age.
You stop there. You don't need to write down 35. You just conclude that both statements together are necessary.
Question 62 wants us to find a specific two-digit number. Statement 1 says the sum of its digits is 9. Statement 2 says the number itself is 5 times the sum of its digits.
Statement 1 is totally insufficient. 18, 27, 36, 81, they all add up to 9. Too many options.
Yeah, it doesn't help.
But look at Statement 2 alone. A two-digit number that is 5 times the sum of its digits. Without even doing the algebra, if it's a multiple of 5, it has to end in 5 or 0. The only number that works is 45. Statement 2 gives you a single unique answer. Therefore, only Statement 2 is sufficient.
That's a great shortcut.
Yeah.
Question 63 asks for the length of a rectangle. Statement 1 gives an area of 120 and a breadth of 8. Statement 2 gives a perimeter of 44.
From Statement 1, area divided by breadth gives length. That is a guaranteed single answer. Statement 1 is sufficient.
And Statement 2.
Statement 2 gives a perimeter, meaning length plus breadth is half of that, which is 22. But that could be a length of 20 and a breadth of 2, or 12 and 10. There are too many variables, so only Statement 1 is sufficient.
Yeah. Question 64 asks if x is an even integer. Statement 1 says x squared is an even integer. Statement 2 says 3x is an even integer.
If a square is even, its root must logically be even. Statement 1 proves it. If 3 times a number is even, since 3 is an odd multiplier, the number itself must carry the even trait. Statement 2 also proves it. You don't need both. Either statement alone is perfectly sufficient to answer the question.
And the grand finale, question 65. What is the profit percent on an article? Statement 1 says it was bought for 500 rupees. Statement 2 says it was sold for 600 rupees.
To find a percentage, you need the distance between the cost and the sale price. A cost alone tells you nothing. A sale price alone tells you nothing.
Right, you need the whole picture.
You fundamentally need both pieces of information to establish the relationship. Both are needed.
And just like that, you did it. You just successfully navigated an entire 35-question quantitative aptitude section.
That's huge.
You went sequentially from 31 to 65. You didn't jump ship. You didn't give up when the fractions looked scary. And you didn't fall for the impossible 110% trap.
It is a massive accomplishment to hold your focus for that long. Remember, consistent, patient practice turns these diverse topics from terrifying hurdles into predictable patterns. We started this deep dive talking about the paralysis of walking into a gym and looking at the heavyweights.
But look what you just did. You picked up the 5-pound dumbbell, then the 10-pound, and you just kept moving. You laid every single brick, one by one, until the structure was finished. But before you step out of this mental gymnasium today, I want to leave you with a thought inspired by those last few data sufficiency questions. because the logic there applies far beyond standardized testing.
Oh, I think I know where you're going with this.
How often in our daily lives do we stress over a massive problem, losing sleep, trying to force a solution, before taking a step back to ask ourselves, wait, do I actually have all the necessary information to make this decision yet?
Such a good point.
This week, I want you to apply that data sufficiency check to your own real-world anxieties. Because sometimes the answer isn't to frantically solve the problem, it's recognizing that you just need to wait for more data. Usually when we talk about taking a test, there's this underlying expectation of absolute clarity.
Right, like a childhood spelling bee or something.
Yeah, exactly. The moderator stands up, they say a word, you spell the word, and you instantly know if you're right or wrong. It's totally binary.
Correct or incorrect.
Very clean.
Very clean. And I mean, honestly, it's comforting. As human beings, we like things to be straightforward. We just want to rely on pure memorization and, get rewarded for it.
Oh, absolutely. But then
you open up a competitive exam paper, and I am thinking specifically about the IBPS POMT preliminary examination.
Oh boy, yeah.
Right. You're looking right at section 3, the reasoning ability section, and suddenly that comforting clarity is just gone. We're looking at a cognitive landscape that is, well, it's a dense fog.
A total fog. You're staring at this giant wall of text about who is sitting next to whom, or some abstract mathematical chain, and your heart rate just spikes completely. Because you aren't just recalling facts anymore. You're being asked to literally build the logic from scratch, all under a ticking clock.
Which is the absolute definition of cognitive overload. And for anyone listening right now who is deep in the trenches preparing for the specific 2026 exam, we see you. We know exactly how that pressure feels.
It's immense.
It really is. It can feel like the paper is actively trying to trick you.
Definitely. Which is why today we are doing a very special, highly focused deep dive, entirely dedicated to this reasoning ability section. Specifically, questions 66 through 100 from model paper of 07.
We aren't just going to read you an answer key either.
No, not at all. We are going to build a cognitive toolkit. We're going to walk through the entire block of material sequentially, starting from question 66 and moving all the way to the end.
And we're going to do it together. So, if you're feeling stressed right now, just take a breath. Don't worry about the clock. We are here to hold your hand, pace the learning, and ensure absolutely no conceptual stone is left unturned.
Okay, let's unpack this together.
Let's do it.
We've got a real roadmap ahead. We're going to systematically conquer data puzzles, decode syllogisms, map out blood relations, and finally crack those intimidating series and ranking scenarios.
Building that logical muscle with patience.
Exactly. So let's jump right into the first major challenge the exam throws at us, which starts at question 66. It's an age-based relational puzzle.
A classic. It's a way for the test makers to warm up your brain or, completely freeze it, depending on how you approach it.
Right. So we have 6 people, P, Q, R, S, T, and U. And we're given this dense paragraph of clues about how their ages relate to one another. When I stare at a paragraph like this, my brain immediately tries to process all 6 people at once. How do we avoid panicking?
It's all about finding your anchor. In these relational puzzles, the fog clears the moment you find the absolute value.
The absolute value, okay.
Right. The exam will almost always bury one solid, undisputed fact right in the text. Here, the text explicitly tells us P is exactly 66 years old.
Oh, I see it.
That is our rock. You don't need to hold all 6 people in your head. Just plant your flag at P being 66, and from there, we follow the logic chain, one single link at a time.
All right, let's trace that chain. If P is 66, the next clue says Q's age is exactly half of P's. Well, that's easy. Half of 66 makes Q 33.
Perfect.
Then it says R is 3 years younger than Q. So 33 minus 3 means R is 30. That feels super manageable. But then the puzzle throws a curveball. It says T plus U equals 18, and T is twice the age of U.
And this is where panic usually sets in.
My brain just screams algebra and wants to shut down completely.
Which is a totally natural reaction, but it's just a simple substitution in disguise. Think of it visually. If T is exactly twice as big as U, imagine T is 2 building blocks and U is 1 block.
Okay, I'm picturing it.
Together, those 3 equal blocks add up to 18. So if 3 blocks equal 18, 1 block just has to be 6.
Oh, wow. Meaning U is 6. And since T is 2 blocks, T is 12.
Exactly. Much less intimidating when you visualize it.
Right. So much less. And finally, the last clue says S is twice as old as T. Since T is 12, twice, that is 24. So just by pulling that one thread, the whole sweater unraveled.
You've got the master list now.
Let me read it back. Key is 66, Q is 33, R is 30, S is 24, T is 12, and U is 6.
And this is the beautiful part. Once you have that master list, the barrage of questions attached to this puzzle, questions 66 to 70, they become completely effortless.
It's so true. Looking at question 66, it just asks for the exact age of S. We know it's 24.
You're reading off the list.
Then question 67 asks for the difference between P and R. Well, 66 minus 30 is 36. Easy.
Yep.
Question 68 asks who the third oldest is. Looking at our list, P is first, Q is second, and R is third. So R is the answer.
Notice how all that anxiety just vanishes once the abstract data is mapped into a concrete list?
It really does. Even for question 69, when it asks for the average age of all 6 people, it's just basic arithmetic. You add them all up, which gets you 171.
Right, and divide by 6.
Yeah.
Exactly, which gives 28.5 years. And then the final question of this block, question 70, tries one last trick. What will be the sum of the ages of Q and U after 4 years?
And the trap there is forgetting that time passes for everyone.
Oh, right.
Right now, Q is 33 and U is 6, which totals 39. But you have to add 4 years for both of them. That's 8 extra years in total. So 39 plus 8 is 47. If you only added 4, you'd fall right into their trap.
Brilliant. We just turned a totally confusing paragraph into guaranteed points. So we've successfully mapped numbers. But the next block of the exam forces us to shift gears entirely. Moving into questions 71 to 75, we go from mapping ages to mapping physical space.
A linear seating arrangement.
Right. A single row of people, all facing north.
And the fact that they all face north is a massive gift from the test makers.
Why is that?
It means their left and right perfectly mirror your own left and right as you physically look at the paper. It removes a whole layer of cognitive rotation. That is a relief.
Mm-hmm.
So let's lay out the clues we're given. Person A is sitting 12th from the left end. Person B sits 6th to the right of A. So if we start at 12 and move 6 spots right, B is in the 18th position from the left.
Well, I moved so far.
But we are also told B is 9th from the right end of the entire row. And question 71 asks us to find the total number of people in the row. To me, this is a bit like trying to find your specific seat in a pitch black movie theater by just counting the silhouettes of the heads in front of you.
I love that analogy. It perfectly captures that feeling of groping in the dark. And if you're counting heads in a dark theater, you have to make absolutely sure you don't accidentally count the same person twice.
Walk us through it. Why does double counting happen here?
Well, if B is the 18th person from the left and also the 9th person from the right, your instinct is probably to just add 18 and 9 to get 27 total seats.
Right, that seems logical.
But think about what you just did. You counted from the left and pointed at B, then you counted from the right and pointed at B again. You just counted B's head twice.
Oh, so to find the true total, you add the two positions, 18 plus 9, and then you absolutely must subtract 1.
Exactly. 27 minus 1, the total number of people in the row is 26.
That makes total sense when you visualize pointing at the person. So the answer to 71 is 26. Now the prompt also says C sits exactly midway between A, who is in seat 12, and B, who is in seat 18.
So we just find the midpoint.
Right. The midpoint of 12 and 18 is 15. So C is in the 15th seat. Now the specific questions are super easy. Question 72 asks for A's position from the right end. Since there are 26 total and A is 12 from the left, 26 minus 12 is 14. But to include A in the count, we add that 1 back in. So A is 15th from the right.
Spot on. The same logic, just in reverse.
Then question 73 asks how many people sit between C and B. We know C is 15 and B is 18. So the people between them are in seats 16 and 17. That's just 2 people.
Look at you flying through these.
Once you have the map, it's just reading the data. For question 74, D is 4th to the left of C. Since C is 15, 15 minus 4 means D is 11th from the left. And finally, question 75 asks how many persons are to the right of B. B is in seat 18. Total seats are 26. So 26 minus 18 leaves 8 people to the right. We methodically organized the space.
You did. But the exam doesn't let you get too comfortable.
Definitely not. Because the very next block, questions 76 to 80, ups the spatial stakes dramatically. We go from a nice, orderly straight line to a circular seating arrangement. 6 people around a table.
Here's where it gets really interesting.
Oh, wait, I was supposed to say that. Here's where it gets really interesting.
Oh, sorry, go ahead.
No, it's fine. It gets interesting because not everyone is facing the center of the table. Some face the center, some face outside. This feels like the ultimate spatial reasoning stress test.
It really is because it forces your brain to constantly flip perspectives. When everyone faced north, your left was their left. But in a circle, if someone faces the center, their right is counterclockwise. But if they turn their chair around and face outside, their right suddenly becomes clockwise. The cognitive drain of flipping back and forth is exactly what they're testing.
So what's the survival tactic here for our listeners?
Empathy. Seriously.
Empathy. Like feeling bad for the people in the puzzle.
No. If you ever feel lost in a circular arrangement puzzle, just imagine yourself sitting in that specific chair. Physically orient your mind. Take a breath and ask, if my stomach is facing the table, which way is my right hand? If my back is to the table, which way is my right hand?
Okay, let's put that into practice. The clues tell us U faces the center. V sits second to the left of U and also faces the center. X sits exactly between them but faces outside. So if we map this out clockwise on our scratch pad, we have U, then X, then V.
Right. Continuing the clues, W sits second to the left of V and faces the center. Z sits immediately to the right of W and faces outside. And the last person, Y, faces outside.
Okay, so if we map this out clockwise around the entire circle, the definitive seating order is U, X, V, Z, W, Y. The inward facers are U, V, and W. The outward facers are X, Z, and Y.
And once that circle is drawn, the questions are just about tracing your finger. Let's hit question 76. Who sits second to the right of Z?
Well, Z faces outside, so right means clockwise. 2 seeds clockwise lands on Y.
Perfect. Question 77 asks for the number of persons facing outside.
We listed them earlier, X, Z, and Y, so that's 3 people.
Question 78. Who is diagonally opposite V?
Looking across the circle, it's Y.
Question 79 asks for the immediate neighbors of Y.
That would be W and U.
And the final one in the set, question 80. Who is third to the left of X?
Let's see. X faces outside, so left is anti-clockwise. 1, 2, 3 seats anti-clockwise is W. Wow, it really is just satisfying once the map is drawn. But just as we master physical space, questions 81 to 84 flip the script again. We leave spatial mapping entirely and move into abstract language rules, syllogisms.
Deductive logic. This is where things get philosophically interesting.
Okay, the exam throws these statements at us, like in question 81. All forks are spoons, all spoons are plates. And then it asks which conclusions follow. Is it all plates are forks or all forks are plates? Wait, so even if a sentence makes literally no real-world sense, like all forks literally being spoons, we just have to accept it. My brain instinctively rejects the premise.
What's fascinating here is, and this is crucial, syllogisms do not care about reality. They test pure structural logic. The test makers intentionally use words like forks and spoons to trigger your reality bias. They want to see if you can override your common sense with pure logic.
So how do we override it under pressure?
Think of them as physical containers. Forget what a fork is. Just picture a small box labeled forks. The rules dictate you must put that small box entirely inside a medium box called spoons.
Okay, small box and a medium box.
Then that medium spoons box must go entirely inside a massive box called plates. So is the forks box inside the plates box?
Yes, definitively. It's nestled all the way inside. So all forks are plates is correct. That was conclusion 2.
Right, only conclusion 2 follows. But if you reverse it, are all plates forks? The answer is no, because there is plenty of empty space in that massive plates box that isn't taken up by the tiny forks box.
That nested box analogy is perfect. Okay, what about question 82? Some clocks are watches. No watch is a bell. The conclusions they offer are all clocks are bells, or some bells are clocks. My visual brain pictures a Rolex and a giant church bell, but I know that's a trap.
It is a massive trap. Use the Venn diagram approach instead. You have a clock's circle that slightly overlaps with the watch's circle, but the watch's circle has a strict restraining order against the bell's circle. They can never touch.
Okay, so the clocks that happen to sit in that overlap with watches can never be bells. But what about the rest of the clocks?
Exactly. We don't know anything about the rest of the clocks. The prompt doesn't tell us. So we can't definitively say all clocks are bells, and we can't definitively say some bells are clocks. Because it's uncertain, neither conclusion logically follows.
The rule of syllogisms is, if it's not guaranteed, it's false. So neither I nor 2 follows for 82. What about 83? Some hills are rocks, all rocks are stones.
Well, the rocks are fully inside the stones box, and hills overlap with rocks.
Which means the hills must also overlap with the stones box. So conclusion I, some hills are stones, definitively follows.
Spot on, only I follows.
Okay, last syllogism, 84. No bird is a snake. All snakes are reptiles. The conclusions are some reptiles are not birds, and some reptiles are snakes.
Well, if all snakes are reptiles, then clearly some reptiles are snakes. So conclusion 2 follows. And since snakes can never be birds, those reptiles that happen to be snakes can never be birds.
meaning some reptiles are not birds. So both conclusions I and 2 follow.
Exactly. You're natural at this.
So when the exam moves from stripping away reality and syllogisms to stripping away words entirely, we get to questions 85 to 87. Mathematical inequalities. This is where they just give you a chain of letters and greater than signs. Like in 85, F is greater than G, which is greater than or equal to H, which is strictly greater than J. If they give us a string like that, my eyes glaze over.
When dealing with a long chain of inequalities, think of it as finding the weakest link. Imagine you are walking a path from F to J. If there is a direct path and you encounter even one strict greater than sign along the way, which we do, right before J, the entire relationship between the two endpoints becomes strict.
So F is absolutely strictly greater than J. That's conclusion I.
Precisely. That strict sign is the weakest link for equality. Once the equality is broken anywhere in the chain, F can never equal J. So conclusion 2, G equals J, is definitively false. Only I follows.
So that saves you from having to plug in imaginary numbers to test the theory. Looking at 86, K is less than or equal to L, which is strictly less than M, which equals N.
Same weakest link rule.
So the path from K to N has a strict less than sign, meaning N is strictly greater than K. That's conclusion I. And M is strictly greater than L. That's conclusion 2. So both I and 2 follow.
Exactly. But what if the chain is broken in the prompt? Like in question 87, P is greater than or equal to Q, comma R is strictly less than Q, comma S is strictly greater than P. The exam asks if S is greater than Q or if R is greater than or equal to S.
All those commas.
When they give you broken pieces, don't try to solve it in your head. The trick is to physically write them out and look for the bridge variable, the letter that connects the separate islands.
Oh, I see. Q is in the first piece and the second piece, and P connects the first piece and the third piece.
Exactly. So use the bridge to build one megachain.
Okay, let's scold it. S is greater than P, which is greater than or equal to Q, which is strictly greater than R. Now it's easy. Following that single path, S is strictly greater than Q. So conclusion 2 follows. And R is definitively the smallest, so conclusion I is false. Only 2 follows.
You just built a bridge right over the cognitive fog.
I love that.
Yeah.
All right, let's bring logic back to the human element for questions 88 to 90. Blood relations. These questions always sound like someone aggressively explaining a complicated family feud at a holiday dinner.
It's so true.
Like question 88, M is the brother of N, N is the wife of O, P is the daughter of O and N. So how is M related to P?
Just map it. P's parents are O and N is the mother. M is the mother's brother, so M is the maternal uncle.
Simple enough. But then question 89 is a descriptive riddle. A lot of points to a portrait and says, she's the mother of my son's wife's daughter. And we have to figure out who the portrait is.
These riddles are totally designed to tangle your working memory. The absolute safest way to handle them is to work backward. Start at the very end of the sentence.
Okay, the end is my son's wife's daughter. So my son's wife is my daughter-in-law. Her daughter is my granddaughter.
Perfect. Now take one step backward in the original sentence. Who is the mother of your granddaughter?
Well, the mother of my granddaughter would be my son's wife again, my daughter-in-law. So the woman in the portrait is Lata's daughter-in-law. Working backward literally unties the knot.
It's a lifesaver. And it works beautifully for the coded relation questions too, like in 90, where they say $Q means P's the father of Q. And the question asks what $Q$R means.
You just translate the symbols step by step. P is the father of Q, and Q is the father of R, meaning P is the grandfather of R.
Exactly.
From navigating family trees, the exam shifts us back to navigating the physical world with direction sense, from 91 to 93. Like question 91, Ritu walks 8 meters south, turns left and walks 6 meters, then turns left again and walks 8 meters. Where is she relative to the start? Do we really need to spend 2 minutes drawing a perfect map for this?
If we connect this to the bigger picture of exam strategy, you actually don't. You can treat these movements like vectors. Think about it. She walks 8 meters south. 2 left turns essentially mean she does a U-turn and walks 8 meters north.
Oh, the 8 meters north and 8 meters south completely cancel each other out.
Exactly, they evaporate. All that's physically left is that middle leg where she walks 6 meters east. Treating opposing directions as vectors that cancel out saves massive amounts of time.
That is so smart. For question 92, it says southeast becomes north. What will west become?
Well, from southeast to north is a 135-degree anti-clockwise rotation. So just rotate west 135 degrees anti-clockwise.
Which lands perfectly on southeast. And question 93, B is 10 kilometers north of A, is 10 kilometers east of B. D is 5 kilometers south of C. Where is D relative to A?
Just sketch a quick grid. B is straight up from A. C is to the right of B. D comes halfway back down from C?
So relative to A, D is both to the east and to the north, meaning D is northeast of A.
Spot on. Now, speaking of time, as we move into the final blocks of the paper, time becomes your biggest enemy, which brings us to series completion, questions 94 to 96, pattern recognition.
Question 94 gives us 2A, 4C, 8E, 16G.
Split it up. Numbers first, then letters.
The numbers double, 2,
Yeah.
4, 8, 16. So the next is 32, the letters skip 1, A, C, E, G, to skip H, and it's I. The answer is 32I.
Easy.
But then question 95, Z, X, U, Q, L. They're going backward.
Map their numeric positions in the alphabet. It drops by 2, then 3, then 4, then 5.
So the next drop is by 6. L is the 12th letter. Minus 6 lands on the 6th letter, which is F. Got it. But question 96, 3, 10, 29, 66, 127. When I see numbers growing like that, panic sets in. What is the fastest way to spot a pattern?
My biggest tip, always check the differences between the numbers first. Is it growing like a ripple in a pond or a tidal wave? If the differences are small and steady, it's basic addition. But if a tidal wave is coming at you, like going from 29 to 66 to 127, there's a heavy multiplier under the surface, stop adding and start looking at squares and cubes.
Let me test that. 3, 10, 29. Okay,
Yeah.
1 cubed is 1, plus 2 is 3, 2 cubed is 8, plus 2 is 10, 3 cubed is 27, plus 2 is 29. That's the hidden formula. Number cubed plus 2.
Yep.
So for the next, in the sequence, after 127, it would be 6 cubed, which is 216, plus 2. The answer is 218. Recognizing that tidal wave growth totally saved me from endlessly trying to find an addition pattern.
That intuition is exactly what the test is measuring.
Now we enter the final sprint, questions 97 to 99. Order, ranking, and coding. This feels like the combination of everything we've talked about.
It really is. Let's look at 97. 32 people in a row. Shyam is 9th from the rear, and Ram is 7 places ahead of him.
Okay, if Shyam is 9th from the rear, out of 32, his position from the front is 32 minus 9, which is 23, plus 1, so 24th from the front, and Ram is 7 places ahead, so 24 minus 7 makes Ram 17th from the front. But wait, in 98 we do this again. 40 students total. Mohan is 11th from the top. Sohan is 4 places below him, making Sohan 15th from the top. Then it asks for Sohan's rank from the bottom.
Right.
The formula says to take the total, subtract the top rank, and add 1. So 40 minus 15 plus 1. But why do we always have to add that random plus 1? But I hate memorizing formulas I don't understand.
And you shouldn't have to. The plus 1 isn't random at all. It's called inclusive counting. Let's walk through the mechanism. If there are 40 students total, and you subtract Sohan's top rank of 15, you get 25. But what does that 25 actually represent in physical space?
I guess it represents the 25 students standing behind Sohan in the line.
Exactly. It's the people behind him. But the question didn't ask how many people are behind him. It asked for Sohan's actual rank from the bottom. If you just say 25, you are pointing at the person right behind Sohan. To find Sohan himself, you have to add him back into the equation.
Oh, so 25 people behind him plus 1 step forward onto Sohan himself makes him 26 from the bottom.
Exactly. The plus 1 ensures you aren't accidentally erasing the very person you were looking for.
That makes so much sense. It's just like the double counting rule we learned in the movie theater analogy earlier, just applied in reverse. Okay, and what about the coding question, 99? If sky is blue is coded as patana, and sea is deep is latasa, and sea looks deep is paasa.
You just find the overlapping words. Imagine taking a red pen.
Okay, is appears in the first 2 sentences, and ta is the only shared code between them.
So cross them out. Is equals ta. It's just matrix elimination.
Right, and sky is in the first and third sentence, sharing the code pa. So if sky is pa and is there is ta, the only word left in the first sentence is blue, and the only code left is na. So blue equals na.
Which brings us to the final question of the section, question 100.
We made it.
The ultimate constraint, time itself, a calendar puzzle. If the day before yesterday was Saturday, what day of the week will it be on the day after tomorrow?
After 34 intense logic puzzles, my brain really wants to overcomplicate this.
Don't let it. Simple timeline mapping prevents silly errors under pressure. Draw a little timeline on your paper. The day before yesterday was Saturday.
That means yesterday was Sunday. That locks today in as Monday. Tomorrow is Tuesday, meaning the day after tomorrow was Wednesday.
And just like that, the fog has lifted.
Wow. You know, if you are listening to this, you have made it through a dense 35-question intellectual workout. You didn't just survive it, you systematically conquered it. You mapped seating arrangements by subtracting double counts, you decoded syllogisms with nested boxes, you untangled family trees by working backward, and you rode the tidal wave of number series.
You should be incredibly proud. The cognitive toolkit you are building right now is what will carry you through. Consistency in this kind of deep mechanical understanding, not just rote memorization, is your absolute superpower on exam day.
It really is. We've spent this entire deep dive stripping away the noise to find the absolute truth hidden in these puzzles. But before we sign off, I want to leave you with a thought that extends beyond the exam room.
This raises an important question. If logic puzzles teach us to strip away emotional noise to find the absolute truth in a confusing paragraph, how might applying that same syllogistic thinking to our daily anxieties change the way we view our everyday problems? What if your worries are just a puzzle with a weakest link waiting to be deduced?
Something to ponder while you rest that brain of yours. Keep practicing, keep trusting your logic, and we will see you on the next deep dive.